Good morning. I'm going to go ahead and start this morning, and there's several people that are coming in as we go, so it's going to be a minute before everybody gets here. I'm just going to go ahead and start because what I do is I upload if you have your I have a teacher's edition geometry book, but and that's what I go with. I use. If you have your green geometry book, or if not, it doesn't matter. You can still follow me. And we'll go straight into what we're supposed to be doing today. I found out that this software that I'm using cuts me off after 40 minutes, so whether I'm recording or not. And I'm just going to go ahead and start straight into it. So here we go. Good morning. We're going to do section, I believe it was chapter 9. Let me see where I stopped last time. Okay, these are the notes that we took last time. If you don't have access to my video from, well, everybody has access to my last video. It's on my YouTube account. And I'll type at the end, well, in just a second, I'll type in my YouTube account link into the chat room here, or either on Microsoft Teams. I'll add that on so you can go and watch the old video of these notes. The last time that we took notes, we did area of trapezoid, area of rhombus. We did the formulas for circles and polygons. Circles and polygons. We did circumference, area. We did the area of a polygon, and we got to Apothem, that term there, and we finished with this formula and did not get a chance to complete this part of the lesson. So if you want to go back and just pause and rewrite this. I know this is hard to read right there, but that's, kind of the nature of the beast here. So we've got information here that you need to turn in. And email that to me, or send it through Microsoft Teams, however you can. Now I'm going to go into this, we're going to finish this section 2 today and move on into section 3. But we're going to spend a little bit of time talking about what an apothem is, okay? So if you go back to page 602 in your textbook, it's right here. Page 602, if you have your green textbook. If you don't worry about it. Just kind of follow me as we go. You'll see that same formula follows right here. It's the area equals 1/2 the apothem times the perimeter of whatever shape you're talking about. So in this case, this gets into something that we're not going to talk about as a geometry team. We're not going to worry about tangents, cosine, or sine, because we have not learned that material in geometry. We'll get to that eventually, but at this point, we don't need to know that, okay? So what we're going to do, what you need to know is the more simplistic version of this, which is, let me see if I can pull this up and talk about it just a second. It says, find the area of each regular polygon. So we're going to find the area of this polygon right here, okay? And it's a regular hexagon. A hexagon is 6 sides, and each side length is 6 meters. Okay, so just to put it in terms of reality, like what is 6 meters? Well, 1 meter is like if you were to look at a door and you were to grab the doorknob, a doorknob is about 1 meter high. So think about that. It would be 6 doorknobs high. That's how long each side is. So this is a really big shape here, okay? So I'm going to go, and now everything that I write, I need you to write. So let's take notes today. Let's start off with section 9-2. We're going to write area of regular polygon. Okay, and then off to the side, put your name and get ready to send that in to me. And I don't remember what today's date. I'm not even worried about today's date. So I'm losing track of time because the days are kind of running into each other at this point. So there's 3 sides. I need 6 sides. 1, 2, 3, 4, 5, 6. I'm going to just, now this is not drawn accurately, but I do want you to understand the word regular. Regular means that all sides are equal. That means all of these sides here are 6 meters long, okay? So the formula for the area of a polygon is area equals 1/2 times the apothem times the perimeter. Well, we can find the perimeter easily here, very easily. It's 6 times 6. How do I know it's 6 times 6? Because we've got 6 different sets of 6. 1, 2, 3, 4, 5, 6. So if you went all the way around and added up all those 6s, you would get 36. 6 times 1, 2, 3, 4, 5, 6. That's 36. So half of 36 would be 18, right? But I did not talk about this little a here, which is called the apothem. The apothem here is should be pretty easy to understand that the apothem goes from the center of your shape. And to be honest, when you're dealing with carpentry or any kind of woodwork or any kind of work for that matter, you can find the center of any shape by where their diagonals cross like this, okay? So if you were to draw a diagonal here, draw a diagonal, you can find that it's kind of like how you'd find the center of gravity, okay? You can look where their diagonals cross. And that intersection point is where, where the actual center of the shape is. Now, if you'll notice, we talked a while back, a couple of days ago, about the area of a triangle. And in this case, if you'll look at this, you can see it's kind of like the area of a triangle. Think of it like a hexagonal pizza. You've got 1, 2, 3, 4, 5, 6 slices like that, right? And you've got a height and a base. But the height and the base are separated by a right angle, just like that. But I don't know what the height is, okay? You would think it's 3, but it's not. What you need to know is right here, that this length from here to halfway across would be 3. This length, okay, now let's look at this just a second. Now, this length right here, from here to here, it says that it's going to be 3 square root of 3. Now, we're just going to go with it the way they have written it down here. But there's more to it than that. It's actually, you can use the Pythagorean Theorem on this to figure out that height right there. And so, you know, they're going to, they talk to you about how to actually calculate the apothem here, which is 3 square root of 3. That's not really what I'm worried about right now. What I want you to understand is how to find the area of the shape and where these numbers go. So in this case right here, this is 3 square root of 3. That's the apothem. That's the height to the center of the shape. That's what that means. From the bottom to the center, that's how the height of that line is called the apothem. And this is where you might, get a little confused because there's a square root involved here. Just keep that square root right where it's at, and let's talk about the perimeter. It was 6 times 6, which is 36. Half of 36 is 18, right? And then 18 times 3 times the square root of 3. 18 times 3 is 54, okay? And so now I gotta click on something over here. I got some problems going on here. So we got 54, and then the square root of 3 is the final answer. And if you look down here, they have 54 square root of 3, which is approximately 93.5 meters squared. Now remember, area is measured in squared units. Okay, so that's why that square is there. All right, now like I said, we're not going to get into this part right here. I'm not really worried about that. I'm just going to hit a couple of practice problems here, and then we're going to move on to section 3. All right. So we're going to go back to the very beginning. So over to the right-hand side of your notes, over here in this little section, I want you to do a, let's call this our practice area. Okay. I'm going to draw a line to separate the notes from the practice zone over here. All right. And so we're going to go find number 1. This is on page 600. I'm sorry, 603. Page 603. And I'm going to do number 1. I'm sorry, number 2. Number 1 is a vocabulary term. It says describe how to find the apothem of a square with side length s. It says draw a segment perpendicular to a side with one endpoint at the center. The apothem is 1/2 s. I'm not going to discuss that right now. I just want to go down here and talk about number 2. Number 2 is a circle, all right? And we want to find what's called the circumference. So what I'm going to do is I'm going to draw a little arrow like this. Think of this like a snake coiled up around itself. And his face is at his tail, right? So if you were to stretch this snake out all the way out, what you would get is a length that's called the circumference, all right? The circumference of circle C, it's called circle C because of the center of the circle is labeled C. They're saying that the diameter of the circle is 10 over pi centimeters, all right? So we have 10 over pi centimeters. Now, the circumference formula is, well, there's 2 circumference formulas. There's 2 pi r, which I don't want that one because we don't have the radius, or you can say it's just pi times d, which is the diameter of the circle. So this is the one we're going to use, and we're going to rewrite circumference equals pi times the diameter. In this case, it's 10 over pi, right? I'm going to slide that over so you can see that. So this circle and this formula are what I'm working on right now. And if you'll notice, because there's a pi out in front and a pi underneath the fraction, these pi's cancel out, and we're left with only 10 centimeters for the circumference. So my final answer is 10 centimeters, all right? And that matches up with what the book has in the teacher's edition. So this shows how to get that. Now let's move on to area. Tell you what. Yeah, let's do area of a circle. And then we'll go down. I'll skip down to number 6. Yeah. Okay. All right. So we're going to do number 3. We need to talk about the area of a circle. So I'm going to draw the circle first. All right. And then we're going to put a dot in the center. There's A there. That's the circle A. That's what that's called. And now this is called the radius because it goes from the center of the circle out to the outside. So it doesn't go all the way across. It's not a diameter. It's a radius. Okay. So that means we're going to use this formula for the area of a circle. And that formula is pi r squared. You need to memorize that. That's important. Okay. Now, what is the radius? The radius is 3x, and we're going to square that. And so what happens here is, well, you see the answer here is 9x squared pi, right? Well, so what I want you to understand is this square can be given to each term inside of the parentheses here. So another way to write this would be 3 squared times x squared, okay? Kind of like that. It's almost like distributive property, kind of, you know, but using exponents. So in this case right here, 3 squared is 9, right? Then x squared comes next, and your pi comes last, okay? So the way you would write this would be 9x squared pi, and this is in terms of inches. squared. Why is it inches squared? Because of area, okay? Area is measured in squares. If you were to take a bunch of squares inside the circle like this and count these squares, you would count this amount of squares. That's what that means, right? So this is how your notes should look so far on your paper. And so this is my whole sheet of paper here. So I'm going to fill in as much as I can down here in the next couple of minutes, okay? Now let's go to the next section. With the next set of problems, I'm going to skip down to number 6 because I want to start talking about polygons for just a second, all right? Number 6 on page 603. So I'm going to come over here and draw a line, trying to keep my notes neat and tidy here. I'll tell you what, let's keep this section right here in notes, and let's keep on coming down with our number 6 here. Let's keep all of our practice problems on this side today. Just trying to be neat and orderly today, okay? And this is a shape. This is a 1, 2, 3, 4, 5, 6-sided shape. This is called a hexagon. 1, 2, 3, 4, 5, 6. And I drew that terribly. And let's move on. There's my nasty looking hexagon. All right, so now we're going to go from the center out to the corner. That's kind of, you can think of it like the radius of a circle, but in this case, it's not. It's not even the apothem. The apothem would be to the base, which makes a right angle. So that would be that dotted line right there. Okay, so keep that in mind that this is not the apothem. All right. Now it says the area of a regular polygon round to the nearest tenth. Okay, and so let's, if you'll notice, we've got 259.8 inches squared is the answer. And so we're going to go back and show you a few things. So this is called the area of a, you remember what it said? Regular polygon, right? Regular hexagon. Okay, hexagon because there's 6 sides there. All right, now I'm going to take a second. This is 10 inches, right? So I'm going to put that 10 right there. And let's go back and look at the book for just a second to see how they would handle this. And I want you to see where they're coming from here, okay? So if you were to look at the area of a regular polygon in the book, it's on page 601 in your book. Do you have it? I'm going to zoom in on this. There's that formula again. All right, so area equals 1/2 AP. All right, well, P is the perimeter, right? That's what it says there, and A is the apothem. All right, and so there's going to be a little bit of fine tuning on this problem to try to get it to be exactly what we want to get the answer. So we're going to have to come over here, and we're going to have to do some work to this problem to make sure everything is nice and neat and orderly. All right, so we know this from here to here is 10. That means, I'm going to, extend this out. That means that from here to here is 10, right? So it's almost like a circle at this point. So if you look at this section here, this would be a 20 inches long, right? This section right here would also be 20, and this section right here would also be 20. So 20 across, 20 across, 20 across, and then this is 10, 10. That means, now remember, this is a regular hexagon, so that means all sides are the same. If I can put a tick mark on every side and say, okay, well, this is regular, this is all equal on all sides. Well, if that's the case, then guess what? This right here is also 10 over here. So we've got what, like a triangle shape that is an isosceles 10 by 10, or 10 and 10 there. Now this over here is what is this length at the bottom? Well, that's what we're fixing to find out in just a second, okay? So I'm going to draw this shape like that. Now, let's see. Let me pause just a second. I want to pause the video and come back to this problem in just a minute. So, all right. So we're going to pause right here. Just put, I'll put a little note here. We're going to do this tomorrow. I'll work this out for you and show you how to get that answer. You know, at the end, I may come back to this and finish this out. I just want you to hang on for a minute because that's not what's really important. We need to get on to 9.3 and I'm limited on time and I don't want to spend any more time on that. I just want you to know that the formula is 1/2 area, where area is 1/2 of the apothem times the perimeter. Well, the perimeter is all the same length all the way around. So that means the perimeter is 6x, right? So it's some amount because it's 6 sides, and the apothem will be what this length is here, this dotted line, and then we'll multiply. So that would mean like 6 divided by 2 would be actually 3x. So another way to rewrite that would be 3x times the apothem. And I'll show you how to get that later, okay? So I'm going to leave that just like it is. Just go ahead and write it. Leave it, the blanks there. We're good. All right, we're going to move on to the section 9.3, okay? Section 9.3. And let's talk about composite figures. All right, so I'm going to put up here at the top of my notes, I'm going to put 9-3 composite figures. Okay, and what is a composite figure? Here's the definition. It says, a composite figure is made up of simple shapes such as triangles, rectangles, and trapezoids and circles. To find the area of a composite figure, you find the areas of the simple shapes first and then use the area addition postulate. Well, the area addition postulate is what we need to write down. I don't know if I think we already wrote that down. Let me go back a couple of pages. Okay, area addition postulate is on section 9.1, I believe. I think we talked about this last week. Let me go back. Here it is. Area addition postulate. It looks like this. So we've got a bunch of little, this is like a composite figure here. So if you were to find the areas of each part, you would add all the areas together to get the total area of the composite figure. And the area of a region is equal to the sum of the areas of its non-overlapping parts. That's called the area addition postulate. We've already written that down, okay? So basically, this area, this composite figure right here, can be broken down into probably 2 or 3 different shapes, depending on how the numbers lay out here. So we're going to write out example A and solve example A, and then we're going to write out example B and solve example B, all right? So we're going to take notes now. Off to your 9.3 composite figure side, we're going to split this into 2. So draw me a line down the middle, just like this. We're going to do part A here and part B here. We're going to put that composite figure shape and description here, and the other composite figure is going to be on this side. So let's draw the shape the best we can. All right. Now it's not going to be to scale, but hey, nobody's watching, right? So, all right. So this side right here is 12 from here to here. This side is 27. I have my advanced chemistry teacher or advanced physics teacher when I was in high school would always say, 27 what? 27 unicorns? No, you have to say 27 centimeters, all right? You have to say the units whenever you write down a number. You can't just write the number down. You have to know how long that is. Now, we're going to divide this shape. I'm going to slice it right down the side right here, just like they did on this. This is a dotted line. Well, actually, make that a dotted line right there. And we just divided it into 2 figures. Now, look, right here, we've got a right angle at this corner, that means this is a base and this is a height, right? This is a base and this is a height. So you could say, okay, you technically have a right angle here. I mean, technically have a base and a height here. You could figure out the shape and then cut out this amount, right? Well, that's one way to handle it, but we've got other ways to do this, okay? So area equals base and height for the top, okay? And then the next one is area equals base and height for the bottom. Okay. All right, so the top part here is going to be easy. We can just go straight into it and say the base is 15 and the height is 12. And then multiply it together and we get 180 centimeters squared. That's not the answer. That's part of the answer, okay? Now we go down to the other part here and we say the base is 27. That's obvious. And the height here, this whole length is 21 centimeters, all right? Well, if you take 12 centimeters away from that, what you're left with is this little section over here, which is 9. 9 plus 12 makes 21. So this section is 9, and that means over here, this section must be 9 too. So I'm going to put a little bitty 9 right there in the corner. All right? And so we've got 27 times 9, which is 243 centimeters squared. Now, these two areas added together, the top and the bottom, make the entire area of the composite figure. So, so we're going to say 180 plus 243 equals 423 centimeters squared for the total area. So I'm going to put total area. All right, and that's our first shape. Let's go over to the second shape for just a second and talk about it. It's got a circle, a circular semicircle involved here. It's got a triangle and it's got a rectangle. So this is actually 3 shapes in one. One big shape. Imagine it without the dotted lines there. So we're trying to get the area of this entire shape here. So I'm going to draw it the best we can. So we're going to slant this, make it a little triangle. I'm going to dot a little line like this. And we'll come down, make a rectangle here. And then a semicircle just like this. So, all right, so we've got 3 shapes, a triangle on top, a rectangle in the middle, and a semicircle on the bottom. So they're saying that this length is 10.2 feet. Right? Is that what they say? Okay, and then they're saying that this length from here to here is 7.8 feet. Right? The height of the rectangle is 3 feet. Okay? And so we can figure that out maybe by subtraction, and we'll get to that in a minute. This is a right angle, obviously. And that's all they give us. So let's go through and see what we can do here. So we're supposed to get 3 areas. So we're going to say area of a triangle is 1/2 base times height. All right? Area of a triangle is 1/2 base times height. So I'm going to put triangle here. And leave myself a space for me to work that out. And then I'm going to come down. And I'm going to put the area of a rectangle. That's the formula for the area of a rectangle. Give myself a little space, come down, and let's work out the area of a semicircle. Now, a semicircle is half of a circle. So you're going to say half times the area of a circle, which is pi r squared. So these are 3 formulas that you really need to learn, memorize, and lock into your brain, okay? And so let's go back and look at how the book handles this. They're saying that the area of the triangle is 9 times 4.8. Well, how in the world did they get 9? Well, if you go back up here, it says they divided the figure into parts, and the base of the triangle is this. This looks to me a lot like the Pythagorean Theorem. Remember a squared plus b squared equals c squared? Well, that's where they're coming from here. So that's what's fixing to happen, okay? So if you'll notice, we've got a triangle. I'm going to come down underneath down here and work out a little bit of extra scratch work. Okay, so this down here is my little scratch work area. I'm going to find the area of the triangle. So the way I do that is, I'm going to need the lengths of the sides in order to do that. Well, the longest side, the hypotenuse, is 10.2, right? So that goes right there, 10.2 will go right there. I'll pull this back so you can see what I'm doing. Now, the things I don't know are the other two sides. Well, you would think that, actually, but I do know the length of this side right here, this little short part here. Well, from here to here is 3, and from here to here would be 4.8, because a total of 7.8. It'd be 3 plus 4.8 makes 7.8. So I can come over here and write down that this length is 4.8 squared, right? And now all I have to do in order to find this other length is to solve for that length there. And if I subtract 4.8 squared from both sides, I can reduce this out and get a squared equals, let's see, we get 10.2 squared minus 4.8 squared. And so now at this point, let's look at what the book says here. They're showing that the square root of 10.2 squared minus 4.8 squared is 9 feet. I'm going to prove that to you with a calculator. So let's go back over here and look at this. So I'm going to type in the square root of 10.2 squared minus 4.8 squared equals 9. See that? I don't know if you can see that clearly on the screen, but that's that radical bar goes all the way across like that. Make sure that happens. That happens every time. So why did they square root? Well, in this case right here, they had a squared. What we need is just a, the length of one of the sides of the triangle. So in order to get that, you square root both sides. And that square cancels out when you square root both sides. And then we get an easy 9 feet. All right. So now we go back up here and we say, okay, what was this length? This was 9 feet, right? So, and what was the height of the triangle? The height of the triangle was 4.8 feet, right? So let's rewrite this out. So we got area equals 1/2 times 9 times 4.8, and that equals 21.6 feet squared. 21.6 feet squared. All right, that's part of my answer. That's not all of my answer. There's still 2 parts here. Now look, I don't know how much time I've got left, but I think we'll probably have to quit after we get through to this section, and your notes will only be this long today, okay? Now I'm gonna add to these notes tomorrow. So just keep this blank area down here, and we'll finish up tomorrow using 9.3 using this section right here, okay? All right, so now let's go back to the rectangle. This is the easiest part because the rectangle is already figured out for us. So we're going to get the base and the height. I'm going to call 3 my base at this point, and then the height we just found out was 9. We used the Pythagorean Theorem to find that length. Well, it's also this length as well. So this is a right angle there. And your base and your height are always separated by right angles. So this is going to be feet squared. So far we've got 2 areas. we've got 21.6 feet squared, and we've got 27 feet squared. We can add these together to make this composite shape. But we're not through yet because we still have the semicircle, okay? Remember, a semicircle is kind of like a circle. Well, so I'm going to put this little dot in the middle. And if I put that dot in the middle, that's going to give me the diameter, right? So this would be the diameter of my circle. And if you'll remember, the diameter is twice the length of the radius. So this radius is actually half of 9. All right, and so when we come over here and work out the formula, we get 4.5 is my radius. And if you calculate that out in your calculator, you should get 10.125 pi. All right, so I'm going to put 10.125 pi feet squared. All right, so I'm going to box that off. In my total area, so I'm going to draw this all the way down. This problem is really long here. There was some scratch work in here. I'm going to box off that scratch work so you can see what's happening. So down here, the total area is 21.6 plus 27 plus 10.125 pi, and then you add all that up, and I get 80.4 feet squared. Okay, so that's my final answer there. I'm going to go ahead and wrap up this lesson here. Now, I'm going to spend a little more time before I leave you on this section right here. And then I'll show you more detail. I'll actually use this whole section right here to write out how to solve that tomorrow. Just don't have the time to show you right now because the video is going to cut me off. All right, but what we covered, if you have any questions, just type them in the chat down there. If you need me to show you a certain section, but this is what I want you to email me, is these notes right here, okay, with the blanks and all. Now, I know it's hard to read some of this because I wrote so small, but I'm trying to fit all of your notes onto one page each day, and that makes it easy to take a picture of and upload, okay? So I'm just going to go until this thing shuts me off time-wise. If it shuts me off at a certain point, I'll just start where I wrap up tomorrow, okay? All right, so 6 sections, all equivalent, the area. So all I have to do is find the area of one section here, and the area of this section would be equal to area equals 1/2 base times height. And so to get that height is a little bit more advanced, but you do know that the side lengths are 10. So you could technically break this down into smaller chunks, like this little shaded triangle right here. You could say, okay, there's 1, 2 in each slice of pizza. So like if you took this little slice right here and made it into 2 slices of pizza, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.